morning and Jai Hind dear students. Today I am going to start the module 3 which deals with lightning. In this module we are going to study what is lightning, how lightning is caused, why lightning strikes tall buildings or tall trees, what devastation lightning can cause and what precautions can be taken by us to save ourselves from this destructive natural phenomena. So let's begin. The picture which you see here, it's related to the Benjamin Franklin's famous kite experiment. In 1752, on a dark June afternoon in Philadelphia, USA, the 46-year-old Benjamin Franklin, an American scientist, decided to fly a kite. With the help of his son William, he attached his kite to a silk string, tying an iron key at the other end. Next, they tied a thin metal wire to the key and inserted the wire into a leaden jar, a container for storing an electric charge, as you can see in the figure. Finally, as the sky darkened and a thunderstorm approached, they attached a silk ribbon to the key. Holding on to the kite by the silk ribbon, Benjamin flew the kite, and once it was aloft, he went into a barn so that he would not get wet. When a storm cloud passed over Franklin's kite, the negative charges in the cloud leaked into the kite, his kite string, his key, and the leaden jar attached to the key by a thin metal wire. Franklin, however, was unaffected by the electric charges because he was holding a dry silk string which insulated him from the charges on the key. When Franklin touched the key, he received a shock because the negative charges in the key were so strongly attracted to the positive charges in his body that a spark jumped from the key to his hand. This experiment showed that lightning was actually due to static electricity. Now Franklin realized that this form of electricity would be charged over a conductor and passed into the ground. He invented the lightning rod and the lightning conductor. Now let's study about lightning, how it is caused. So what is lightning? Lightning is a rapid flow of electric charges through the air between two oppositely charged clouds, seen as an intense spark of electricity in the sky. Now you know that clouds contain tiny crystals of ice and droplets of water which move against each other. This can cause huge amount of charge to build up in the clouds. Ordinarily, nothing happens due to the charge buildup because air does not conduct the charges from the clouds. It is a very poor conductor of electricity. But when the accumulation of charge becomes so large enough and the wind brings the two clouds together, you can see the two clouds have come closer. What happens? The insulation of air and the charge can break down. So you can see the insulation of air has broken down, and what happens? The charge can jump from one cloud to another cloud. The passage of electric current in the air due to movement of electric charges is called electric discharge. I repeat again, the passage of electric current in the air due to movement of electric charges is called electric discharge. You can see here from one cloud the charges are moving on to the other cloud and from the second to the first. So this creates an electric discharge. The sudden rush of electrical charge heats up the air to about 30,000 degrees Celsius, producing a bright glow of lightning. During the process, a huge amount of energy is released in the form of heat and light. Due to the heat produced at the time of lightning, the air gets heated up and expands suddenly. This rapid expansion of air molecules sends a disturbance in the form of vibrations through the air, which produces the loud sound. And this loud sound is called thunder. So finally, we have understood how lightning is caused and how thunder is produced. One more thing we have to keep in mind, that the lightning is seen first and thunder is heard later. Why is it so? Because The speed of light, it is around 3 into 10 to the power 8 meter per second, or 3 into 10 to the power 5 kilometer per second, whereas the speed of sound is only 340 meter per second in air. So you can imagine the huge difference with which the light travels and with which sound travels. So we are able to see the lightning first. Now coming to the next slide, why does lightning strike tall trees or tall buildings? So when we talk about it, why it is advised to us that during lightning we should not uh, stand under the tall trees. So as you can see in this diagram, a cloud has negative charges at the bottom. So you can see the negative charges are concentrated at the bottom and the positive charges are in the upper region. When a charged cloud passes over a tall building or a tall tree, it induces opposite charges on the tall trees. So you can see this cloud is passing over the tall trees, and what it is doing, since the base of the cloud has more of negative charges, and it is producing opposite charges, that is positive charges on the tall trees. The negative charge at the base of the clouds pulls the positive charge induced on the tall buildings or the tall trees upwards at a tremendous speed. As soon as the negative and positive charges connect, a continuous path is formed from the cloud to the tall trees on the ground. The large amount of negative charge accumulated in the clouds rushes down with this path, giving rise to an electric discharge in the form of lightning strike. When electric charge flows between a charged cloud and a tall building on the earth, we say lightning has struck in the form of lightning strike. What are the harmful effects of lightning? A lightning strike generates a huge amount of electric charge. The lightning bolt has a temperature of about 30,000 degrees Celsius. So this temperature, high temperature, can cause a great devastation. It can cause fire and shatter buildings, resulting in a lot of destruction and damage to the property. It can burn trees and also cause forest fires. It can injure or sometimes even kill animals and human beings instantly at the spot. Coming to next slide, how we can prevent ourselves from lightning. So we are going to discuss lightning conductor. What is lightning conductor? Lightning conductor is a device which is fixed on the top of the tall buildings to protect them from damage due to lightning. So this is the lightning conductor you are seeing, which is passing over the side of the building onto the ground. Now it consists of a long lightning rod of iron or copper with a number of sharp spikes at the top end. So you can see these are the sharp spikes at the top end. These are made up of iron. This is connected to a long rod which is passing along the sides of the building and then finally to the ground. Now as this rod runs, the lower end of the rod is connected to a metallic plate, usually a copper plate, which is then buried deep inside the earth. When the lightning strikes the building, this lightning conductor, it provides an easy path for all the charges to pass on through the spikes then to the rod and then finally to the earth, and thus it protects the building. In absence of such lightning conductor, the current from the lightning will pass through the buildings, thereby causing a lot of damage to life and property. So what are the safety measures that we can take to prevent ourselves from lightning, or what precautions should we follow to save ourselves from lightning? So some of the precautions that we should follow, do's and don'ts for lightning safety. So what are the do's and don'ts? Avoid tall objects like trees and utility poles. Don't go near tall trees or utility poles. Second, seek shelter in low-lying areas. It is better for us to seek shelter in low-lying areas, and we should avoid water bodies, and we should also avoid downed power lines. Then, in addition to this, if we are in a group of people, stay about 15 feet away from each other and do not lie flat on the ground. Open vehicles like scooters, motorbikes, tractors, open cars, open fields do not protect us when lightning strikes. Quickly come down from the elevated places like from the top of the hill, the summit or mountain or the rooftop of a building. If you are in forest, take shelter under shorter trees that are less likely to be a site of lightning strike. And try to appear as small as you can by crouching on your knees on the ground. Place your hands on your knees with your head between the hands. This position will make you smallest target to be struck with lightning. Other measures we can take indoor are stay away from the windows, do not use telephone, do not bath when lightning is occurring, avoid electronic equipments, do not wash dishes, and unplug all the electrical appliances, and do not lean on the walls. So these are some of the measures through which we can save ourselves from lightning. So this module is over, and in module 4 we will be discussing about the next destructive natural phenomena, which is earthquake. Thank you. Jai Hind.